Good afternoon. We are 2 or 3 days into our word problems with algebra, and some of us are doing very well, and some of us are still struggling a little bit with it. Remember, when we do it, there is a set formula, and we do it a set way each time to make it easier for you to get it done. So the first step whenever we're doing a word problem is that you have to do a diagram. You have to draw a diagram. You have to label the diagram. That diagram is going to be the basis for the equation that you have to make up. So it has to be a labeled diagram. That's the first part. You have to put that this is x or this is x plus 2 under it. And I made you a promise when we did it that you'll always have over here the same letter for the entire equation. It's always going to be an x and then another 2x or something in there where you'll have to collect like terms. You'll never have an x and a y and a z and a b. You'll never have multiple variables in that sense. They will always be variables based off of the initial unknown that you didn't know. After you figure out your diagram and you make your equation, the second step, step 2, is that you have to collect all your like terms. And when you have an x and a 3x and x plus 2, you group all the x's together, and you group all the numbers together so it makes a nice expression or equation that you can solve. And then you go ahead and solve it. Remember, when we're doing this, we don't have to do a check anymore. That's the end of our checks, because you may not have started with the right equation. Therefore, a check may be a waste of time. But you have to go back to the question that was being asked and make sure that you answer it. It not always is just going to be your x value that is the question. It might be asking you about something else. So whenever you get to the last part, you write your therefore and you answer it, but you always make sure you refer back to the question that was being asked. So I've got 3 that we're going to do here. And remember, when we're doing it today, you sit there and talk and pause it when I ask the question. Say, what would you do? Pause it, write it down in your notes, and then hit unpause or play and see if you're right. See if you have what I have when you're doing it. So that's how we're going to work this. So here's the first one. I put the directions again at the top, but pretty small. And we're going to talk right here about the question. Now, the first word problem question is, the sum of Mike and Susan's ages is 54. And Susan is 14 years older than Mike. And how old is each person? As I get ready to attack this question, I will look at some words like sum, and I know that's an adding question. I know Mike has an age, and I know Susan has an age. I know together they're 54. And here it tells me something important, that Susan is 14 years older than Mike. So that's just stuff I will start reading and thinking it through. Now, when I draw my picture, they're really easy. I just draw a guy and a girl, and I could do that with hair. Now, of course, you could draw, there's my girl, that must be Susan right there. You could put an M, this is Mike and this is Susan. But anyhow, you need a little small picture, but that is labeled to a degree, but you actually have to have your variables in there. So we don't know how old those 2 people are, and you have to find the base one, which is the smaller one. I go back to this part of the question right here. So if Susan is 14 years older, that must mean Mike is just the x value. He's the base that the rest of it is being put off on or compared to. And I know that Susan is the same age as Mike, but 14 years more. So I will represent Mike as x and Susan as x plus 14. When I go to write this as an equation, that there is Mike. I'm going to add in Susan right here, and remember, it was sum, so that's how I knew I was adding, and together this whole thing is going to be 54. The solving is not the hard part. We have to remember to collect our like terms, and once we get to this stage, so many of you are so confident doing it. We're going to get rid of the plus 14 by doing the opposite operation to both sides. You're going to subtract 14 from that side. 2x is equal to 40. Then we get rid of the 2. So x would be equal to 20. When I'm at that point, all I need to do now is to use my therefore statement. Remember, a therefore statement is a triangle of circles, and it asks me how old each person is. Mike is X, so he's just this answer right here. Mike is 20 years, and Susan, because she is X plus 4, sorry, X plus 14, she must be equal to 34 years old. And there's my whole question answered. 1 mark, let me use a different color. 1 mark for the labeled diagrams, 2 marks for the math work, and 1 mark for your therefore statement. All right, let's hit the next one. In this next one, we say that the question here is the sum of 3 consecutive numbers. Well, first I have to know that there's 3 of them. There's consecutive, and we know what consecutive means, one after another. So it's 5, 6, 7, Monday, Tuesday, Wednesday, January, February, March, whatever is next in line. And I know that the total of it is 93, but I don't know what the 3 numbers are. So again, you start with your diagram. I'm going to say this is the first number, the second number, and the third number. I'm not saying 1, 2, and 3 are the numbers. 1, 2, and 3 don't add up to 93. But I'm saying this is the first number. Now the first number, I don't know what it is. And that's the whole point with algebra. So you let it be a value that you don't know. We're going to let it be x. I always use x because I like making the fancy x. Anyhow, the second number in that series has to be 1 more than the first one, because that is what consecutive is. If the first letter was x, the first number was just x, this one being 1 larger has to be x plus 1. Similarly, the third number is 2 more than the original. So the original was x, and it's going to be x plus 2. And in this way, when I do the sum, because remember I'm going to add all this, I'll have the first number, I'll add it to the second number, and then I'll add it to the third number. And together it's going to equal 93. The first thing I have to do is collect my terms. I count up all my x's there. I see that there's 3x. I group all my numbers together. Oops, sorry, that is a mistake. That should say 2. Anyhow, I add up all my numbers. I see that there's 3, and it's equal to 93. Once I'm at this point, like I said, we are strong. We are confident. We know what we're doing. We're going to get rid of that 3 by subtracting it from both sides. 3x is going to be equal to 90 divided by 3 divided by 3. I'm going to need a little bit more of the page. X is going to be equal to 30. Now, in my therefore statement, the first number, or I can just say the numbers, are, now remember there are 3 consecutive. My first one is 30. My second one, remember, is x plus 1, so it's going to be 31. And my third number is x plus 2, so it's going to be 32. This makes sense because 30, 31, 32 are consecutive numbers, and they do add up to 93. When I look to see how that would be marked, remember you get 1 for your diagram, 2 for your math work, and 1 for your therefore statement. We're doing really well, but I'm just going to do one last question with you, and then all it takes is practice. This one, I'll read the question. A triangle has 3 sides with different lengths. The second side is 3 times the length of the first. The third side is twice the length of the first, plus 5 centimeters. And the perimeter of the triangle is 65 centimeters. What is the length of each line? Well, if I'm looking for my important words, triangle is an important word. I hope we all know that triangle has 3 sides. All the sides are different, so none of the sides will say the same value. Second side is 3 times the length. And the third side is twice the length plus 5. And total it equals 65. So if we start, doesn't matter if this is quite to scale or not, we draw up our triangle. And they have 3 different lengths, and it says, you would say to yourself, okay, what is the first length? And we do not know what it is. So of course you will put a variable in its place. So that's side 1 right there. Side 2 says, if you look right here, it's 3 times the size of the first one. Well, if the first one was x and this is 3 times that, that'll be represented as 3x. And the third side right here is twice the size as the first, so it's 2x. But remember that it also says plus 5 more centimeters. The whole perimeter is 65, and we should know that perimeter is the distance around the outside, so we will be adding once again. So to put this into perspective, you take the first side, you add the second side to it, you add the third side to it, and it equals 65. We've done this many times, so now we are going to collect our terms. We're going to do 1x plus 3x plus 2x, and that equals 6x, plus 5 equals 65. We have to get rid of the addition first. We do that by doing the opposite operation to both sides. They cross out. 6x is equal to 60. We're almost there, but we have to get rid of that 6. It's multiplying, so the only way to get rid of it is to divide. Remember that says 60. My pen's a little bit off. X is equal to 10. So that's a good answer, but we have to put it with our therefore statement. So therefore, side 1 of the triangle is equal to 10 centimeters. Side 2, and remember side 2 was 3x. That's going to be equal to 30 centimeters. And side number 3, and remember we represented side number 3 by 2x plus 5. And when I do 2 times 10 plus 5, that's going to be 25 centimeters. So look and see how we marked one last time. 1 mark for the diagram, 2 marks for the math, 1 mark for the therefore statement. If you haven't done many of these in the last couple of years, you may start to panic. Take your time. Think it through. Really understand the picture and what's being asked. Then if you follow it slowly and collect your terms, and you should be good. Please ask questions. We're going to do this for the next couple days, and then we're going to be moving on to something else. So I'd rather you have it down before we move on than teaching you something new and then you having to come back in a week or so and say, oh, what about those word problems? I still need more help. So let's put a big push in the next couple days to really get these squared away a little bit. All right, thank you.